Hello and welcome to SudoKanard. The recent puzzle Ramayan, round 4 of 2022, was totally created by young Indian author Nityant Agarwal, and it contained 3 Kropki puzzles, and I'm about to solve them. They were very good puzzles, a bit harder than expected, but well, I managed to solve them, and I was glad I could, because not everybody managed to solve all the number puzzles, and it was quite a hard round. So the rule of Kropki is that whenever you have a white dot between two cells, the numbers are consecutive. Whenever you have a black dot, it means that one of the digits is double the other, and all such symbols are given, meaning that here you can't have consecutive digits, you can't have digits with a ratio of 2 to 1. So this also follows the rules of Latin squares, meaning that every digit here from 1 to 6 must appear exactly once in each row and each column. And let's start. So here is a place to start. We have 2 sets of 3 consecutive digits, meaning that one of them must be 1, 2, 3, the other one must be 4, 5, 6. So this digit is 205, this digit is 205. But 5 wouldn't work here with a black dot, because this would have to be 10 or 2.5, and that is not allowed. So that's a 2, that's a 5. So 5 is surrounded by 4 and 6. 2 is surrounded by 1 and 3. So this is 2 or 6. But note that if this were 2, then this would have to be consecutive with 2, and we would have a white dot here. So that's not 2, that's 6, that's 3, that's 1, and this is 5. Now for 6, this has to be 2 or 3, and then we must ask what happens here. We have 2 sets of 2 consecutive digits, so one of them must be 1 and 2, the other one must be 3 and 4. So if this is 3, then this has to be 4, but then we have consecutive digits here, but no symbol between them. So that's actually a 2, and it's with a 1. And here we get a 3-4 pair, but 4 is not next to the 5, so that's a 4, that's a 3, and that's a 6. Let's move on. Here there must be 3 and 6, but 3 is not next to the 2. That's a 6, and that's a 5. Here we need 1, 2, and 4. Consecutive digits are necessarily 2 and 1, and that's a 4, and that's a 2. And that can't be a 1, so that's a 3. So this is a 4, 1 is not available. We get a 6 down there. This now can't be 3, so it's 5, that's a 1. This is not 1, so it has to be 4. 4, 5, 6 wouldn't work, so that's 4, 3, 2, and that's a 5 to complete the row, 1 to complete the column. We need 2, 3, and 6, consecutive are 2 and 3. That's a 6, and let's finish with those digits. So that was a nice start, and I certainly took much longer to solve it during the contest. Well, that's just a warm-up. Let's move on. So that's an 8x8 grid, so digits 1 to 8 must be placed. And a nice place is here. We have 3 digits which form what we call a geometric sequence. So every digit is double or half the preceding one. So they must be 1, 2, 4 or 2, 4, 8. And in the middle it's 1, 2 or 4. And the interesting part is that if you try to make this one, then this has to be 2, this has to be 2, and then the same argument that we've seen a few minutes earlier happens here. this is consecutive with 2, but there's no white dot here, so that doesn't work. And the same is true with 8. If you put 8 here, then this must be 4, this must be 4, and there you have a digit that must be consecutive with 4, but not consecutive with 4, which is nonsense. So this is not 1 or 8, so it has to be 2 or 4. And one option is 4, 2, 1, and the other option is 2, 4, 8. 1 comes with 2 and 3, 8 comes with 7 and 6. A place of interest is this, which is a famous configuration in Kropki puzzles, especially in Kropki Sudoku. Here we have 2 consecutive digits, so one of them must be even and the other one must be odd. And both of them are with a black dot, and an odd digit with a black dot can only be 1 or 3. But you can't put a 1 in here, because then this would have to be a 2 and this would have to be a 2 as well. So the odd digit here is a 3, and that's true here as well. And we're in the situation of an X-wing, meaning that those 2 columns must have exactly 2 3s, and we've located both of them. So either we have a 3 here and a 3 on the other end of the diagonal, or it's the other way around. An interesting point here is that if you put a 3 here, then this is a 6, and this is 3, but there's no black dot here, so this can't happen. So 3 is actually here and here, together with 6, and 6 here with a 3. And now this must be a 3, so that's a 2, that's a 1, 2, 4. That's not a 2, so it's an 8, and that's a 7. Now next to 3 here we have 2 or 4. Same here. And note that this can't be 2 or 4 because it's next to a 3, so it's 1 or 8. Next to 6 we have 5 or 7. Here it's the same. This can't be 2 or 4, so this is 1 or 8. And next to the 3 it's not a 2, so it's a 4. This is 5. It's not next to 4, so that's a 2, that's a 1. That's a 2, that's a 1. And here we need 6, 7, and 8. But next to 6, this is 7. So this is 6 or 8, but 6 here would put a 3 there. That doesn't work. So that's 8 with 4. And that's a 6 with 5 or 7. But 5 would be next to the 4 without a white dot, so that's a 7. That's not a 3, so that's a 5. And then, where should we look? Perhaps this row. Yes, we have 2 pairs of consecutive digits. One of them must be 4, 5, the other must be 7 and 8, but 7 and 8 are both unavailable here. So 7 and 8 are here. And this is 4 and 5. 8 comes with 4. This can't be 8 because of this 7 and the lack of a white dot, so this is 2. 2 and 4. So the only possibility here is 3 and 6, and without the white dots, here we have a 3 here and a 6 here. That works. This can't be 4, so that's a 6. The column still needs 7 and 8, so that's 8, that's 7, that's a 4. This column needs 1 and 3, there's a 3 on this row. This row already has 1, 3, and 5, and we need an odd digit here, so there must be a 7. 6 is not available, so that's a 7, 8 pair. The remaining 2 digits are 2 and 4, so that's 2, that's 4. Here we need 1, 3, and 5. That can't be 5 because there's no white dot. That can't be 3 because there's no black dot, so that's 1. 3 is here, that's a 5. This is not 4, so that's a 6. Here we need a 1, so that's here, and that's a 3. Next to the 3, that's not a 2, it's a 4. That's a 5, not a 3. We need a 2 in this column. It's here with 8 up there. That can't be 3, so that's a 1. Here that's a 2. No, that's a 4, 8 pair, so that's 4 here, 8 there. Here, this can only be a 5. So that's a 7, finally. This is 2. Here we need a 6 and a 7. 6 is not next to this 5. 7, 6. 6 or 8. Oh, but there's an 8 here. So that's 6, that's 8. And the remaining digits are those. Nice. So let's move on to the third Kropki puzzle, which was the highest pointer of the 3. And again, in 8 by 8 grid. So where do we look? There again, we have here sequences of 3 digits in a ratio of 1 to 2. So they must be 1, 2, 4 or 2, 4, 8, but one can't be at either end because it would be surrounded by 2 2s. The same would be true here. So that doesn't work. That's 2, 4, and 8. So 4 is in the middle, surrounded by 2 and 8. And here, the other way of satisfying this black dot is to have a 3, 6 pair. But those are consecutive. So that's a 2, that's a 3. That's 6, that's 8. We still need to put 1, 5, and 7, but neither 5 nor 7 is here for lack of a black dot, of a white dot, so that's a 1. This is now 7, this is 5. Surrounded by 4 and 6. So now this 4 is followed by 5 and 6, or by 3 and 2. And that's interesting because here, as I mentioned earlier, it's either 1, 2, 4 or 2, 4, 8. But in both instances, you see that there's a 2 somewhere here. So this can only be a 6, and that's a 5. This is now 2 or 4. This can't be a 5 anymore, so that's a 7. And we can ask where 8 goes in this row. It's not next to 7, it's not here. It's not next to 7, so it's here. So this can't be a 4 because that would be a black dot. That's a 2. We still need 1, 3, 4, and 6. This can't be 1, this can't be 6. So that's 3 or 4. 1 could be either of these. Let's have a look at this. What could we have? 1, 2, 4. That seems to work. 2, 4, 8. No, sorry. 2, 4, 8 wouldn't work because of this 8. And the other way around. 1, 2, 4 wouldn't work because there's a 4 in this column already. What about 2, 4, 8? That works. So this is consecutive with 2 or 4. Can't be 5, so it's 1 or 3. And note that this can't be 6 because there's no white dot here. So 6 is here on this row. And that's a 4. And this is 3 or 5. Oh, and this is also 3 or 5. So we have a remote 3-5 pair here. So this will either be 2, 3, 4, 4, 3, 2, 4, 5, 6. Well, that's not so interesting, I'm afraid. Where does 3 go in this row? It's not here next to the 6, it's not here, could be here with the 4. Actually, this can't be a 3, and this can't be a 4. 3 wouldn't be next to this without a white dot, 4 wouldn't be next to this, well, 4 would make this a 2, it would need a black dot. So 4 is here, and 3 is there, and that's a 1, so this can't, 3 is there, I say. So this can't be a 2 without a dot of any color, so that's 4, that's 8, that's 2, and this can't be a 4 anymore. This is 3 or 5. We need all odd digits here. 7 is not here, 7 is not here, so 7 is here. 1, 3, and 5. No 3, neither 3 nor 5 works here. There would be a dot here, so that's a 1. That's 3 or 5. So that's 3 rows almost completely done. Here we have 8, 6, and 4. We need an even digit here, so it will be a 2. And actually, 2, 3 here is not an option, because 2 wouldn't be here, and 2 would have to be there, and a white dot would be needed. So that's a 5, that's a 6, and this can't be a 3 without a black dot. There must be a 7 down there, accompanied with an 8, by an 8. I never know about this. Oh, that's a 3, sorry. So that's a 2-8 pair. 2 will come with 1 or 3, but 3 won't be here. 7, so that's 1 or 7, but this could be a 3. Well, that's not so interesting. That's the trickiest part in the puzzle. Where do we go from here? This column looks interesting because 5 digits remain. 3, 4, 5, 6, 7. There's a set of 2 consecutive and a set of 3 consecutive. So it could be 3, 4 somewhere and 5, 6, 7 here. In which case this is a 6 and a 3, 4 up there. Or up there we have 6 and 7. So that's the other option. 6, 7 up there and 3, 4, 5 down there. In which case this is a 5 and this is a 4. Well, I can't seem to find directly what this is. So what digit? I think digit 2 is very constrained in this row. Can't be next to the 1, can't be next to the 3, can't be here obviously, can't be next to the 4, can't be here. So 2 is here. And that's 3, that's 5, that's 4, sorry, that's 6, so that's a 4. Surrounded by 2, 3 and 5, but 3 is not here. So that's now a 5. This must be a 2. So this is 8 with 7. That's a 2, and that's a 1. 2 and 3 up there. Here we need 1 and 5. This can't be 4, so that's a 6. This can't be 7, so this is 8, and 7 goes here. We need 1, 7, 8. 8 is not here. 1, 7, 8, and 6. So this is 6 of 8. 1, 6 and 7 are not available. 1 can't be next to these 2, so that's an 8. That's a 6. That's 1, that's 7. Still works. We need a 4 somewhere. Can't be here. There would be dots. And a 7. This is 3 or 5, can only be 3. That's 2. Here we need 6 and 7, so that's 7, that's 6. Here 1 and 4, that's 1, that's 4. Here 5 and 8, and here 1 and 8, so this is 8, this is 1, 8, 5 and 3, and 5, and that's it. So excellent sets of puzzles by Nityant Agarwal. It was an excellent round as a general matter, and I will soon do a video with the Kakuro puzzles, which were great, pretty hard as well. So thanks for watching this video, and see you soon on SudoKanard.